10 to the raised to the x power or e to the x power is o en yellow color o en blue color, ¿no? That means que this key have double function. And the part que es blue or yellow, you need to press the key second, okay? Okay, the same color of the function. Oh, and you know, see the second, the key second, que maybe is blue or maybe is green, no? Depending on the calculator. Because you want, okay, basically this log, okay, because today we studied the standard logarithmic. We studied the function logarithm in general for any base, logarithm base 2 or something, logarithm base 3, or something, logarithm base 5, logarithm 1/2. But this example right here is non-standard. In our calculator, we have a standard. And the standard is base. So basically, we have two standards. The first one is the common logarithm. It's a name, common logarithm. Common logarithm is base 10. Entonces, base 10, remember the example we are doing in the last class, is very intuitive to understand. And this is the reason que the common logarithm is used in science, chemistry, physics. Everyone you use in logarithm in the science, you use in common logarithm. And the notation is log. Well, do you say, no, professor, it's the same, log, pero no specification the base. And with the no specification the base, default, you need to understand the base is 10. This is common thing in the test, I promise. Okay, put equation, complicated equation, to say no specification the base, and say, well, professor, I don't understand what's the base in this logarithm. The reason is que es common logarithm and the base is 10. Okay, you never write like that. You write like that. Log of x, because you suppose default get the base is 10. Okay, now let's practice a little bit using the calculator. For example, you typing in your calculator. Everyone follow me. You typing, for example, 100. No, 100, no. You type in the key log. Bueno, put in on the calculator first, no? You type in log, you see log automatically in the displays, and you type in log, you see in the display, this is the display, you put this log and open one first parenthesis. You type it inside 100, for example, and close the parenthesis. You know, in the keyboard, we have parenthesis, open parenthesis, and close the parenthesis. You type in only close the parenthesis because open was open directly with the name of the function, and press enter key, enter equal, enter is equivalent to say equal sign, and you get the answer, right? Boom, the answer is 2. The answer in the bottom here in the second line of the display, you see 2. And it's obvious, you know very well, the logarithm base 10 of 100 is 2 because logarithm 100 base 10 is equal, I don't know, without calculator we are doing the last class, is expressed to exponential statement, the base is 10, get this 10, the exponent is the thing I tried to looking for, is equal 100, but 100 is 10 to the second power, same exponential, same base, is because the exponent is the same. Okay, super. This is the common. This is the common. Es estándar. Base 3, base 2, base 1/2, no está. And the second logarithm is a natural logarithmic. Okay, also we have in our calculator. And this is using in calculus. it's hard to explain the advantage of the natural and calculus. Because in calculus you apply another operations. Okay, when you apply onto the natural logarithm is easier than the common logarithm. Okay, but the thing you need to know is that the base is E. E is a symbolic way to indicate one irrational real number. E is approximately, because irrational means irrational number. Irrational is a number that we cannot express it like a fraction, never. So if you try to express like a decimal, you have infinity non-repeated decimal. And this continues forever in completely different pattern. Suppose that you need to visualize in your calculator E. Well, we're using that key. The same key here is LM. I want to explain LM, but we're using the function above, is e to the x. And you press. You clear the display, clear the display. Now you press second and select this key. In order to select the blue or the yellow, whatever you want to call it. Entonces immediately you see in the display, look, display. You see E, that symbol, open parenthesis. This is e to the x, e to the something. Remember, in the calculator, open the first parenthesis. And you put inside here, by curiosity, no? One. This is just e, no? You put one, close the parenthesis, and press enter. Again. And you see the answer in below is 2.71828182, depending on the approximation. And also some calculator you can set up the own approximation, or another no, another like this calculator have only 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal place after. Okay, so this is the E. E we using in calculus, and we use it also here because when you study the application, some application is simulate using natural logarithm. Entonces E is the base of the natural logarithm. And instead of write log base E of something, no, the notation que es common use is ln. The default and no specification any base. No. LM automatically you need to know que es log base E. Likewise, log without specification of the base, automatically you need to understand que es log base 10 of it. Okay, this is the standard. Entonces, bueno, okay. But for example, let's do quickly one computation using LM. Okay. Suppose I want to compute ln of E. Entonces, what should I do? Well, you have in this moment in the display you have E, no? Is this number, no? Entonces the continuation is you press now this key again, but without second. So you press ln, and you see in the display now ln, open parenthesis, no? Entonces inside you put the last answer. Okay, if you want to repeat 2.7182, you can, of course, but it's much better, more elegant. You press and the key second again, and the key second again, but you press one key, que is the negative sign here. This is the TI 30. Above you see answer. Now when you press second, this is answer. Second this is answer. No, I make a mistake on you. Okay, again. LM. Wait. Is I need to repeat the first part. The exponential 1. 2.71. Okay, I did it this step again. Now I press now second answer. Oh no. Oh, I press LN second answer. And you see something like that. Answer. And who is the answer? No, answer I suppose is the last number, no? That we manipulate. Press equal or enter, and the answer is 1. That makes sense, eh? Because logarithm e is 1, no? Suppose I have no idea, put x here. I know that the base is c, default. E to the x is equal e, it's obvious que es e to the 1. X equal. Okay? Everyone understand this? Or we need more example? Or of course, we're working with this now. Because entonces you want a professor, okay, I understand. However, how we compute the logarithm when this non-standard? Because in the real life, you see logarithm of the non-standard number. Okay, suppose logarithm base 3 of 81. Well, we computed before in the last class this. Do you remember get 4? Well, the reason gets 4, let me do by hand. In this case, it's easy. In the other case, no. Because when you compute, you convert this logarithm statement to exponential. The base is 3, this the small 3, I copy big. The exponent is x, 81, equal 81. Yeah, I know that 81 is 3 to the 4th power. That's 81, break it down, 99, 33. Actually, 81 is the multiplication of the 4, 3. Therefore, we have the same exponential. Therefore, the exponent is the same. And the conclusion is x equal to 4. Okay, but let's do this operation using the calculator. When the one formula, a super important formula, in my opinion, is the most important formula. The name of this formula is change of base formula. Entonces, change of base formula say logarithm of the any arbitrary base of x is equal another logarithm of the another arbitrary base b. The a is like a old base and b is a new base I want to change of the same number. The x is the same number divided by logarithm of base b. So b is repeated here of a. Okay, this formula allows us to change the base of the logarithm function, no? So in our specific example, we have logarithm of base 3 of 81. But in our calculator, we have no logarithm of base 3. We have a standard. The standard is base 10 or base e. Okay, no problem. I want to change from base 3 to base 10. So I copy because I suppose that B is 10, in this example, B is 10 is standard, and A is 3 is the base. So I copy log of 81 divided by log, so it's the same. See, I suppose base 10 here, I suppose base 10 here of 3. Okay, because A is 3. Do you see the analogy here? The corresponding position in the equation for the specific example. The A is 3, I put 3 here, and B is 10. The 10 is default. And please, you put in the calculator. Be careful and respect the parentheses. I put it in the calculator. LOG, open the parentheses, 81. Okay, this is my display of the calculator. I type in LOG, I press the key LOG. LOG. Send to the X, but I don't care. I press, this is my display now. Look. LOG. So I typing inside 81. Close the parentheses. I did that part. But don't press enter. No, 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 no. Division now. Division. I press division. And I press now again LOG. So 3. LOG, LOG. LOG, open the first parenthesis of 3. Close the parenthesis. Of 3. Close the parenthesis and press enter. Whoa. And the display I saw is the answer. Exactly, we predict by hand. Put that here. Here, what's for? But I have a question. So, bueno, professor, what is the reason that you select LOG como logaritmo? We can do using ln 81, ln 3. We can or no? And we get the same answer or no? Well, I don't have idea. I suppose it work, right? Okay, let's try. ln now. ln is ln 81, close the parenthesis, division, ln, exactly, ln of 3. And this is totally expecting the answer is the same for. Okay? Therefore, don't hesitate. We can use in our problem we're discussing from now. We're discussing sometimes happen frequently. If we can solve the logarithm by hand, not necessarily calculator, but just in case you want to make sure you using the famous chain of base formula and we compute this. Let's do one more example. Suppose I want to compute logarithm base 2 of 1024. Come on, guys, help me. I don't know if you prefer. Some people, I don't know why, they like so much LOG and don't like LM. But this is the same. It's equivalent. It's equivalent. Come on. Let me know the answer. Please. Tell me. 1.1. Everyone is agree with this answer? Estén. Very, very well, Jonathan. Estén. You put it in estén because let me try my calculator. Is I type in LOG 1024 close the parenthesis division LOG again 2 close the parenthesis present. The answer is very well. You got it. Okay, now I did Bauer. Okay. No, okay. Bauer is 10 to the, no, 10, no, sorry. 2 to the 10 power is 1024. With 1024, so you break it down, divided by 2 is 512, divided by 2 is 128, divided by 2 is, divided by 2 is 32, divided by 2 is 16, divided by 2 is 8, divided by 2 is 4, divided by 2 is 2. So in total, how many 2? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. I need another. I suppose I make a mistake in one bar. Okay, 1024 divided by 2 is 512. 1024 divided by 2 is 512. Divided by 2. I make a mistake here. It's divided by 2 is 256. Coño. And divided by 2 is 112. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 2 to the 10 power. So we can do in this, no, like least long way, stupid way, no. You press, for example, in this key, well, in this key, so to exponential function, we can use in this key. So you type in, for example, 2, and the display, this is the display. You type in 2, just 2. This symbol, it look like a roof of the house, and you put the thing, press enter. Bang, 1024. Okay, super, no problema. Okay, entonces we are ready to study and apply the property, the A property for the logarithmic function. Okay, the next topic is property of logarithmics, like an A, no adjective. Okay, the first one, you know very well, is logarithm of the any base of 1 is equal 0. You know this fact, right? Logarithm of 1, regardless base, is 0, always. Okay, log of 1, 0. ln of 1, 0. log base 2 of 1, 0. And so on, any base. Number 2, everyone follow me? You understand the first property? This is important, extremely important. And I promise we are using any property we study now, we are using every day from. Suppose logarithm of the any base of the same number is equal 1. For example, log of 10 is 1. ln of e is 1. Logarithm base 2 of 2 is 1. So when a number is the same, logarithm base 5 of 5 is 1. Okay, this is the second property. Don't forget this property, guy. Number 3 is a little bit. Number 3 is a little bit weird. It's like any number, suppose que es the base of the one hypothetical exponential raised to the log a of x is equal x. Wow, I don't understand very well this property. Okay, this property is a composition. Do you remember this idea? One function composition is inverse, is equal identity. Or the inverse composition, any function is equal again the identity. It's the only, not the only, but it's one possibility in which you can interchange the function and the answer is the same. Not always that happens. So you apply here, look, let me use in one color. You apply logarithm. This is my first function. And my second function is a composition with one function inside another function. You apply exponential. So this alone is exponential. And this alone is logarithm. And when you composition, remember that symbol is composition, on those each other because they are inverse functions. And the answer is identical. Likewise, that we always can use in the property, you know, when you want to eliminate the logarithm. ¿No? Entonces, likewise, the fourth property is the opposite. O sea, es suppose in opposite direction. Es el logaritmo first, logaritmo second, sorry, and the exponential first. And you put in that order, not in that order. You put the logarithm first, and the exponential second, no? In this case, you switch the order, you put the exponential first, and the logarithm second, no? But this is saying, does each other, and the answer again is identical. Okay? When you want to eliminate exponential, you apply logarithm. When you want to apply eliminate logarithm, you apply exponential. Some book, antique book, no new book, is called the exponential function like anti-logarithm. It's like opposite. But no. And the modern and new books, no. It's exponential and logarithm. Okay, so this is the fourth property. Okay. Okay, number 5. It's important. Logarithm of multiplication to expression is equal m. times m. M times m is two algebraic expression, no? And you apply logarithm of this multiplication, you can separate like that. M plus logarithm of m. O sea, logarithm es magic because separate, o sea, convert product to sum. Product to sum. When you apply logarithm of the one product, doesn't matter que 1, 2, 3, o sea, two multiplication m times m, or multiplication p, q, r, t, you separate several logarithms. This is very useful, and we're using this idea not exactly in that direction, you know, in opposite direction. So suppose one equation, a stupid equation, and you have 5 logarithms. Okay, you solve this long equation. No, you condensing these 5 logarithms in only one using that problem. Okay. Well, why not? Let's prove it. This using this idea. Look, this using the property number. O sea, by curiosity, this is your curiosity. You don't need, you only apply. You don't need to prove anything. You are no mathematician here. Suppose that I want to prove this statement is true. Well, so I using the property number 3. You know, but property number 3 is apply exponential. Suppose that I apply exponential here and exponential here. Apply exponential. Remember, exponential is like an anti-logarithmic. And this is un dos. Boom, boom. This is cancel out. I don't like to put this stupid line. No, it's not polite. The student like, but mathematicians hate that idea. This is not true. It's like a do cancel out f and f inverse. No, it's not good. This is m times m without logarithm and without exponent. And this no, because it's plus. But I know when you have exponent, suppose a to the b plus c, you can separate like a to the b times a to the c. So that when you multiply two expressions, they contain the same base, you add the exponent. This is rule of the exponent. So you separate like a log a of m plus a again, the same base, log base a. I forgot the a. Sometimes I forgot. Okay, it's important. Don't forget the base m. This is m. No. Don't forget the base specification, the base that we are working. And also, some people write like that, logarithm of m. This is wrong, incorrect. You put the parenthesis, always. It doesn't matter if it's algebraic expression or number. So log of 5, because this is like a function notation. Nobody write like that, fn5. What the hell is that? Nobody understand this. F equal to 5, everyone understand. So the parenthesis is important and the specification of the base is important. So this is time, sorry, because remember I convert addition to multiplication, no? Now this is m, it's obvious, time, and this is m. And the proof. Likewise, in the division is subtraction. And the division, the property number 6 is when you have logarithm base a of division now, m divided by m is logarithm base a of m minus, when this division is minus, logarithm base a of m. That's easy to remember because when it's plus, when it's multiplication, sorry, it's plus, it's addition, and when it's division, it's subtraction, opposite operation. No? And what about when it's exponent? When it's exponent, is the property number 7, is log base a. Base a indicates either any base, 2, 3, 10. The expression is m raised to the r power. This exponent I call r, I don't know why, I put in the front like a factor. R times log of a to the m. Okay, entonces en conclusion, multiplication is converted to addition. Division is converted to subtraction. And the exponent is converted to multiplication. Entonces you like decreasing the level of the complexity of the operation, no? Because the most elementary arithmetic operation is addition, no? Entonces when you have multiplication and you apply logarithm, you convert to addition, que es easier problem. And number 8, que is the last one, is the formula that we see before, is the chain of base formula. Is logarithm of the arbitrary a of the one number, hypothetical number that I call x is equal logarithm of the another base that I want to change b divided by logarithm b of a. Okay, repetition again. A represent the whole base. O sea, the original base that you don't like because maybe it's non-standard. I need to solve it by calculator. And B frequently is the new one. And the new one is sometimes, the majority of the case, is the standard. Because we can use the calculator. Maybe 10 or maybe E. Okay? Let's practice a little bit now the example of the, in which you have, for example, you have in both directions. We have, for example, write as a sum of differences of logarithm expressed power as a factor. That we expand, and after we condensing. But first of all, expand, que es easy to understand, in my opinion. No? Expand first. By the way, guys, we are recording the lecture. Yes. Yes, we are. Okay. Suppose. Okay. Logarithm of logarithm of base 17. Wow, this is not standard. Weird. Of the 8 over 19. Entonces, day one, this is a typical question. It's super easy, super elementary. You expand, so you write this logarithm as the sum of differences, Claudia. Wow. Okay, you write several logarithms as a sum of different the logarithmic, and it also express the power, no? In the case we have power, no? In this case, no, we have no power. Okay, so you apply the property number 6. So in this division, you apply logarithm base 17 of 8 minus logarithm base 17 of 19. And you expand in that direction, expand the logarithm from one logarithm to several. We can do in another direction. Okay, we can, of course. But after now, we are doing condensing. Condensing means that we have 2, 3, 4, 5, and you write like a 1. Okay, suppose another example. This was example 1. Example 2 is a little bit more confusing. 18, base 18 of the 7 square root m divided by m. Entonces I can see one. Our algebraic expression contains 1, 2, 3 guys. So I suppose that we have 1, 2, 3 logarithm. The first logarithm is logarithm base 18 of 7 alone. And the arithmetic operation between 7 and square root m is time. We have here invisible period, no? Entonces multiplication is plus. But be careful. The square root, in my mind, working like that. Square root m is equivalent to say m to the 1/2 power. You can write using a radical, but it's more elegant because the problem says that any power, in this case, the power is 1/2, expressed as a factor. So it's 1/2, you put 1/2 in the front, apply the property number 7, logarithm base 18 of m. Finally, minus, because of division, logarithm base 18 of m. That's it. That's it. Suppose one more complicated and long. Suppose we have number 3. Logarithm base. No logarithm. It's ln. Immediately, when you see in one example, ln, you say, well, I understand it's natural. Logarithm of the base is t. It's natural. I don't care, but I know. And so inside we have n to the 5th power, n to the 8th power, divided by x to the 6th power, and y to the 7th power. So this expression contains 1, 2, 3, 4. So I suppose that we expand in 4 logarithms, no? ln x m, m, and the exponent you put in the front as a factor. And the arithmetic operation here is multiplication, no? This is plus 8 ln of m. This is the confusing part. The arithmetic operation here is multiplication, but they are in the bottom, so you are dividing. They are divided, both are negative. Minus 6 ln of x minus 7 ln of y. Let me know if you understand very well that both are negative or no, because I can explain another way, no? So in conclusion, I memorize anything in the top is positive. Plus. Anything in the bottom is negative. Negative subtraction. It's easy to memorize this. Okay. Let me try another example, pero in opposite direction. Suppose I give you the problem several logarithms, 1, 2, 3, 4, and you condense it in only one. Suppose. Example 4 is log base 3 of m plus logarithm base 3 of m. What is my goal? My goal is express as the only one single logarithm. So you see, wow. The base is the same. The base should be the same. See, the base is different. Look, suppose I erase this, I put another base 4. We cannot apply this property. This property is only valid when the base is the same. Okay? Otherwise, no. Entonces you condense it, entonces you realize que you apply the property number 5, no? The property number 5 says when the multiplication is addition, but we are doing in opposite direction. Entonces, logarithm base 3 of m times m. Let me try another. Suppose logarithm base 5 of 4 plus logarithm base 5 of x cubed minus 2 plus logarithm base 5 of 2. And you have to condense it in only one. Okay. Again, it's 3 logarithm. It's plus. It's plus multiplication. You write only one word, log, with the same base as 5, and you multiply everything. This guy times this guy times this guy. This guy and this guy are numerical value. Is 4 times 2 is 8. You open another parenthesis, and inside the parenthesis we have x cubed minus 2. Do you hear a noise, guy? I am living near to the air base in Hunter. This is the noise. Do you hear or no?
Yes, sir. Actually, the airspace manager, I'm an air traffic controller at the base, and they're going to be flying until 9 o'clock. They're practicing.
Yes. Okay, one more example. Suppose example 6. And let's go directly to the point. You understand the property, you are strong to manipulate everything using logarithmic expression. So this is 4 minus Logarithm of base 3 again. Of x. And we need to condense it in only. Okay, okay. A subtraction. See, subtraction is division. And this exponent is 1/2. I move it here to the exponent. No? It's a factor as exponent. So I copy. Only one log because their idea is condensing. Don't forget to write the base. I know it's subtraction here, minus. Therefore, it's division. It's x minus 4 raised to the 1/2 power. Divided by x. And don't forget the parentheses involve everything. Because logarithm have your own parentheses, no? And inside the expression, we have different level of parentheses. You write parentheses or square bracket, either way. This is one good way. Yeah, you can leave it like that. However, in my opinion, more elegant is log base 3 radical x minus 4, no? X is 4. Inside the radical divided by x, and here parentheses. Okay? I suppose it's easy. I suppose you understand very well. Yes or no? Yes or no? Yes or no? Was confusing? Was clear? Yes. Okay, entonces we have the tools anywhere in your hand to solve anything using the logarithm. Entonces, I suppose que you remember this stupid equation. Okay, I left pending for the solution because I have no idea. Okay, remember this equation que one moment I present to you. Entonces I say, no, I have no idea because the only possibility I know is the easy when the number in the right hand side is possible expressed like a power of 2 and you solving this. In this case, no, I cannot. Okay, you can now. Why you can? You apply logarithm. What kind of logarithm? Either logarithm. I prefer standard. LOG or LM. Doesn't matter. The answer does. Entonces you apply logarithm both sides. You apply. Look at the idea because the idea is always the same. You apply LOG. Si you don't specification the base is because the base is 10. Okay. Okay. Now, what's my goal? My goal is solve for x. And so you apply the property number 7, que is the property that allows any exponent you put in the front like a factor. It's a property 7. Let me go with the property 7 because maybe you don't remember very well. It's a property that you have logarithm of the any base of the m to the r. R is exponent, and you copy r like a factor in the front. Log of m. It's magical because this exponent fly to the front. It is magic because in that moment we have no exponential function anymore. This is exponential equation. This is no exponential equation anymore. This is a linear equation because this is the weird part that the student don't see very well. Okay, this is x. This is just a number. Okay, we can compute it in the calculator, and this is another number. A weird number, I know. And so finally, it's like a 2x equals 4. How you solve this equation? Divided by 2, x equals 2. In this case, exactly the same. You divide by both sides by log of 2. This cancels. And x alone, is my goal, is log of divided by log of 2. Okay. You say, well, professor, this is weird. Okay, I understand it's weird. This is the exact answer. Frequently in this problem, we don't need the exact answer. No. We need approximate answer. And this is the moment you play the game, the calculator. And you put in the calculator now. Come on, try. Everyone try in your own calculator. You put in the top LOG using logarithm, of course. You put clear the display, press LOG, 3, close the parenthesis. Be careful with the parenthesis because the student forgot to close the parenthesis. In the calculator language, you type in like that. LOG, open the parenthesis 3, close the parenthesis, division, LOG, close the, open the parenthesis, 2, close the parenthesis, and press enter. Okay, and press enter. Division, LOG, 2, press enter. Bang! I get the answer. Where's the answer, guys? Help me. Typing in your chat the answer. Okay, this is the thing we are doing now. I left you computer by calculator and you give me the answer. I have the answer here. See, the answer doesn't match. You are wrong. 1.6. At 1.58. Okay. Good to see. Very well. This is the answer. Okay. Jordan say the answer is Professor 1.58. I want to copy exactly my display. 4.9, que no necesarily is exactly your display. For this reason, in the test, you need to truncate or round. Suppose que in the test hay specification. Express your approximate answer to the nearest, for example, 4 decimal place. 1, 2, 3, and 4 decimal place. So you analyze the digit after this, because 6, si es 5 or greater than 5, you increasing. Actually, entonces 1.5, 8, and 49 plus 1 is 50. I suppose that you understand very well this rule, no? It's classical in the elementary school. Is you round to the decimal place que the test specify. Okay, sometimes a 4 decimal place, 3 decimal place, 2 decimal place. We suppose here 4 decimal place. Yeah, mandatory. And the test I don't know, I don't remember. Okay, but so far we truncate because this logarithm is irrational number. We cannot express it in one limit digit, no, it's infinity digit, no repeated, irrational number, typical irrational. Okay, do you understand how you solving this? Okay, we have those two kinds of the exponential equation. The nice exponential equation, like that, can you solve it, manipulate both sides, and you convert immediately the exponential equation to linear equation. This is not nice, it's ugly. Ugly. And the ugly, you realize it's impossible doing that way, and you apply logarithm on both sides, and you apply several properties. In this case, you apply the property number 7 only, but not only you apply 7, you apply several properties to solve the equation. Everyone follow me? Sure? So far it's clear? Good. Flora, I say good. Okay, I want to complicate your life. Example 2. Another ugly exponential equation. Another ugly exponential equation. Suppose this 5 parentheses 2 to the x equal 8. Again, solve for x. In the case, okay, of course, we have the logarithmic, you need to apply logarithm, so you round to the 4 decimal place, no? But in this case, it's obvious that we need to apply logarithm, right? Okay. What kind? I don't know. In my paper, I using LM. You like or you don't like? It's up to you. I obey your order. Professor, no, LM no good. Yeah, why no? Why no? Okay, Andreina prefer LOG. Okay, I respect Andreina. Andreina dice, no, professor, no, I don't like this line. Okay, I promise que working perfectly. But okay, I prefer apply LOG. LOG of 5 to the x power equal LOG of A. So Andreina suppose this is base 10, no? Es como un logaritmo que we have available also in our calculator, no? Ajá, entonces we have, wow. We have here multiplication, no? Entonces I apply the property number 6. The property number 6 say que you separate this like a logaritmo of base 5 plus logaritmo of 2 to the x, no? Is equal logaritmo base A. Remember the property number 5? Property number 5 say that when you have multiplication, expression inside the logarithm gets multiplication. I don't know why you apply like addition, separate by addition. Entonces, one more time you apply property number 7 because why not? Because this exponent gets x, I put in the front as a factor. Okay. Entonces, in this moment, it's obvious that we have linear equation. Suppose, do understand. This is the student don't understand very well or don't see very well. Look, this is not true. This is the one mnemonic device to understand the idea. But suppose that in my mind, I remove the word LOG. So the equation is 5 plus 2x equal A. This equation is too easy for you, no? This is the intermediate algebra equation. Yes or no? Subtraction 5 divided by 2 and the story. So in this case, it's not the same, of course, but it's same format because this is a number, this is a number, and this is a number. So of course, it's a weird number, it's an irrational, crazy number, but I don't care because I compute it using the calculator. So you're subtracting, the procedure is the same. You're subtracting minus LOG of 5. Finally, divided by LOG of 2, because my goal is solve for x. So x alone is equal LOG of A. Don't use the calculator now, because I need one more step to be ready to put in the calculator. Okay. Personally, you can put in the calculator like that if you want. But no, I don't like that. Okay. Remember, it's typical rule. When you have several logarithms, you condense it in only one. There are no reason to type it because it's confusing maybe in the calculator. Put a parenthesis. No. You type it in the top, you condense this and this in only one. The logarithm of 8 over 5 because I using now the property number 6. And when the subtraction is division, no? Divided by logarithm of 2. Okay, and this is the moment to using calculator. This is the moment to using the calculator. We have only one logarithm on the top and only one logarithm on the bottom. Let's do it. Is LOG. Inside the parentheses, I put 8 over 5. Okay, you type it like that. Look, LOG. This is the display of the calculator. Parenthesis 8 division 5. Close the parenthesis. Division LOG of 2. Press enter. She said get 0.781. No, a ver, let me see. 0.68, no. Let me see. 8 over 5. Let me try. Division. Because I forgot something in the problem. No. Okay, I did different problem I have in my paper because I forgot something. But no, don't worry. Maybe you are okay. Logarithm of 2. The answer, I want to copy exact the answer. Yeah, you are right. The answer is 0.6 78 07 19 051. This is my calculator. Depending on the approximation of your calculator, truncate the number in. Okay, suppose I want to round to 4 decimal place. 1, 2, 3, 4 is 7. So increasing 0 is 1. The answer I want is 0.6781. End the story. End the story. End the story. We are the best. But I want to complicate more your life. Any question, guys? Do you understand very well? Logarithm, exponential equation, ugly exponential equation. Ugly exponential, very ugly. See, a little bit, no. And Jordan, and the next one is unbelievable, complicated. Look, but don't worry, we are doing exactly the same procedure. Look at that. Suppose this is 2B equation, example 3. Example 3 is 0.3 raised to the 1 plus x is equal 1.7 2x minus 1. Wow. It's obvious that the base is completely different. It's obvious that this is ugly, it's not nice, it's impossible. Impossible to try to express it, both terms using the same base. It's impossible. It's a job impossible. And you apply a logarithm both sides. You apply ln or log. Okay, I know that Claudia prefers log. Entonces in that moment I apply the property 7. It allows us this exponent. This exponent is the expression, no? Apply to the front here. And this exactly they have here. Apply to the front. You're right. 1 plus x. Please don't forget the parentheses. Because this parenthesis multiply log, no? 0.3. So you write without parentheses, look like an x multiply only a logarithm. No, it's not true. This is entire expression is multiplied by this number. And here exactly the same. 2x minus 1 times log 1.7. And don't be scared because logarithm of 0.3 and 1.7 we compute it with the calculator. No? And the moment we have linear equation. And you apply the thing you know in algebra. You apply this distributive property, you multiply this guy times this guy times this. Then you have log 0.3 times 1 plus x times log of 0.3. Likewise here, multiplication is 2x log 1.7 minus log 1.7. So far, everyone are agree or disagree? Or disagree? Everyone following? This is what my goal. My goal is 6. So exactly the same we are doing linear equation. I try to move to the same side. I don't know, see to the left or to the right. The term can contain x. In my paper, I don't know why. It doesn't matter. The way I bring this guy to the left. This state. I bring this guy to the right. Let me see. Yeah, like that. So we have x log 0.3 minus 2x log 1.7 is equal minus log 1.7 minus log 0.3. Oh, crucial moment, because in this moment I saw the x is common factor. Ya hay factorial. Open new parenthesis. Inside we have log 0.3 minus 2 log 1.7 equal minus log 1.7 minus log 0.3. Entonces my goal, remember, is x. You divide both sides. You divide both sides by this guy. Divide by log 0.3 minus 2 log 1.7. I copy exactly the same here. Log 0.3 minus twice logarithm 1.7. And this is cancelled and stay x. X is equal. Okay. Don't put a calculator now because you need to manipulate accommodation this because this is look like ugly. To put 4 logarithm in the calculator without making mistake of the parentheses. No. Okay, this is the answer. I accept. Suppose you get this answer, you get 100 points. But this answer is ugly, absolutely ugly. Okay. I saw one idea. Look, too many negative in this expression. Negative, 3 negative. No, there's no reason to. If you multiply by -1, top and bottom, you change the sign, no? In the top, everything is positive now. It's perfectly legal, right, to do that. And the bottom, no. On the bottom, this is negative, this is positive. I don't know why, I like to put the positive first and the negative second. But I omit something. We have 2 here, right? I omit these 2. Look. These 2. Okay. When I copy, I forgot that these 2 is important. Okay. Now, this is a moment to condensing this logarithm in only one. So I put logarithm of, and so you apply here the property number 5, no? The property number 5 say, go ahead. Say again.
Would the 2 be positive? It wouldn't be -2 log 0.3. Wouldn't it be
positive? You are right. A plus, no? A plus here.
Yeah, so the denominator should be
minus here. Yeah, minus here, right?
Yeah.
Okay, negative and positive and negative. Wait. Let me erase. Actually is this is 2 2 log 1.7 que es positive, negative, positive. I put in the first place minus log of 0.3. Correct now? I did well. Or no? Positive in the top, both. In the bottom, 1 positive and 1 negative. And the positive is multiplication by 2. Si hay condensing, apply the property number 5. The number inside here is the multiplication 1.7 times 0.3, que es 0.51. Okay, what come from 0.51? I put in my calculator 1.7 times 0.3. Present. Boom. 0.51. And the bottom, log. Okay, log of what? Okay, this is minus division. So division 0.3 and 1.7 square. Because I apply in this case property number 6 and 7 together. Because this minus become like a division and 1.7, this exponent go here like a power. Entonces, this is equivalent. I put in my calculator now. Is log 0.51 divided by log. So you put in my calculator 1.7 square divided by 0.3, and the answer is like a 9. 1.63 repeated. 33333. Let me try. 1.7 square. Remember, the square is something like that. You put in the calculator 1.7 square division 0.3. Division 0.3. Boom. The answer is 9.63 repeated. I don't care to repeat it. Well, you want to copy that. Now, this is a crucial moment to using the calculator in the last step to compute the answer. Entonces, you help me now. Okay, but wait a second. In this case, I want to take advantage to analyze si the solution, si the answer is positive or is negative. Okay. I like so much verification if the answer is positive or negative before putting the calculator. Remember, logarithm, the base of the logarithm that we are using is 10. And when the number is less than 1, the logarithm is negative. And this number, no, is greater than 1, the logarithm is positive. As the negative, this answer should be negative, this answer should be positive, and negative divided by positive is negative. So the answer that we expect without do anything, no calculator, is negative. I expect negative answer. I put in my calculator. Help me, guys. You put in your own calculator. What is the answer? And truncate or round to the 4 decimal place. It's negative, no? It's negative something. Come on, using the chat to answer me. 0.3, no. 0.3 is, let me see in my calculator. It's log 0.51 division log. I like that. I like the answer. The answer, well, let me try to finish. 9.63. Yes, you are right. It's negative 0.29. Guy, you need to practice the calculator on the logarithmic. I know that today is the first day, no? But you have to practice. And throughout the rest of the course, we practice a lot of things. Truncate 4 decimal place. 1, 2, 3, 4. Oh, it's 9. So it's 3. The answer is minus 0.2973. Is my final answer. Wow, too much, eh? Okay, but you're using logarithmic and basically you apply the property. Okay? And the 5 minutes that we have, well, any question? Do you understand very well? I know it's too long. And be careful with the algebra because you forgot something like me. I forgot the 2, or I multiplication wrong, the number. Okay? Thank you for your help. One more, very confusing. Ugly logarithmic exponential equation. Exponential. Today was ugly exponential. Next week is the logarithmic equation, que is worse. I hear frequently in the whole of the college, no? The student talk about this topic, no? Not my student. We are going graphic. No, well, yeah, we can float up, but in the first part, we are doing the graph of the logarithm or exponential. That's it. No more complication. The rest is just equation, computation, property. I hear the students say, I never understand this stupid logarithm. I don't know why. Okay, suppose this last equation that maybe we have no time to solve this today. Wow. 4 raised to the x, this is exponent, minus 10 times 4 to the minus x, this is exponent also, equal to it. The beginning, I have no idea. I am lost, totally lost. But I propose you one transformation. So suppose that you multiply the entire equation multiply the entire equation by 4 to the x. Well, how do you know? Well, you know because I have practiced and we solving several. Okay, entonces I multiply the entire equation. When you multiply 4 to the x here, 4 to the x here, and 4 to the x here, we have 4 to the 2x. Because remember, 4 to the x times itself, you adding x plus x is 2x. Okay? Minus, and 4 to the x times 4 to the minus x is 1. Because it's 4 to the 0. If 4 to the 0, I know the 1, so it's just 10. I eliminate. This guy is cancelled. No cancel. Well, it's 1. It's 1. And the right hand side, we have 3 times 4 to the x. Okay, maybe you are lost so far, but I want to give the hint. One hint is, let me write in different way like that. 4 raised to the x squared. Because remember the property for the exponent, when you have a to the c to the b, you multiply it's a c b. So when you have different level, you multiply the exponent. No, is 4 to the x squared is equivalent to the 4 times this guy. 2x or x2 minus, pero okay, entonces I bring this guy to the other side like a minus 3, 4 to the x, this is time, don't forget this period, minus 10 is equal to 0. Oh, now this is, at least for me, it's a little bit more clear. For you, no? For you, no clear? You see something interesting to keep going, progressing in this equation or no? You are lost? Help me, guy. No? No? You cannot help me. Please, I need help. Okay. This is the typical equation that we're solving in the first test. Okay, it's the equation that contains u. Remember u? Why? Because this equation have one piece. It's this piece. Let me use another color. Look, you see that this expression is exactly the same, this expression. But the only difference is this is square and this no. This is 1 power. Then you define 4 to the x like a u. We convert this equation in this equation. Yes or no? And this equation can happen, that situation is called, the name is quadratic. Quadratic in form. It's equation that we can convert to quadratic because we have one weird expression. In this case, the expression is exponential 4 to the x. Yeah, I call you. Entonces we have in that moment quadratic equation. You solve them by quadratic formula, maybe, or you solve them by factorization, maybe. But we finish next time. Okay, next time we continue. Next time we continue. And we repeat again this equation at the beginning. Think about that. Because we solve the quadratic equation, but the solution for the quadratic equation is not the original answer because it's u value, and you need to restore the x value. Okay, so you have after the solution for the quadratic, and after we have the solution for the exponential. Okay.